At 5:58 in the morning, while most of Flores Island was still asleep, the seafloor north of Enda tore open. 10 kilometers down, along a fault line that had been quietly building pressure for decades, two tectonic plates finally lost their grip on each other. What followed was not a single event, but a chain reaction, a magnitude 7 rupture that sent shockwaves racing outward at several kilometers per second, followed within hours by more than 300 aftershocks, one of them powerful enough to be an earthquake in its own right. By the time rescue teams reached the port town of Maumere, they were not searching for survivors in isolated pockets of damage. They were searching through entire neighborhoods that no longer had walls standing. Within 2 days, the death toll had passed 50. Thousands were displaced, sleeping in tents beside hospitals that were treating patients in the open air because nobody trusted the buildings enough to bring them back inside. This was August 15th, 2026. And it was not an isolated tragedy. It was the latest entry in a year that has already produced 10 earthquakes of magnitude 7 or greater, a number that historically represents almost the entire yearly average for the whole planet, reached with more than 4 months still left on the calendar. Something is happening beneath our feet in 2026, and the unsettling part is not that the Earth is shaking. The Earth is always shaking. Somewhere on this planet, a magnitude 4 earthquake occurs almost every hour of every day, and nobody notices because most of them happen in remote regions or deep beneath the ocean where they can do no harm. The unsettling part is the pattern this year has taken. The way catastrophic quakes have struck one after another across completely unconnected fault systems, from the volcanic arcs of the Pacific to the mountain provinces of Afghanistan to the poorest neighborhoods of Caracas. Each one a separate disaster with its own body count, its own collapsed buildings, its own families standing in rubble that used to be their homes. Seismologists have a term for years like this. They do not call it an epidemic of earthquakes, because earthquakes do not spread from one fault to another the way a disease spreads from person to person. But when the numbers cluster this tightly, when the death tolls climb this fast, even scientists who spend their careers insisting that nothing unusual is happening start choosing their words a little more carefully. And by the end of this account, you will understand exactly why some of the same experts who call this a normal year are also quietly warning that the second half of it could bring several more. To understand why 2026 feels different, you first have to understand what normal actually means when it comes to earthquakes. The planet's crust is broken into roughly a dozen major tectonic plates and dozens of smaller ones, all of them drifting against each other at roughly the speed a human fingernail grows. Most of that movement is invisible, absorbed silently along fault lines that creep rather than snap. But where plates lock together instead of sliding smoothly, stress builds for years, decades, sometimes centuries, until the rock finally fails all at once and releases that stored energy as a seismic wave. Around the rim of the Pacific Ocean lies the most active of these boundaries, a nearly continuous horseshoe of subduction zones and volcanic arcs stretching 40,000 kilometers from New Zealand up through Indonesia and the Philippines, across Japan, up the Aleutian Chain, and down the western coasts of North and South America. This is the Ring of Fire, and it is responsible for roughly 90% of the world's earthquakes and 80% of its largest ones. On a typical year, the global count of earthquakes at magnitude 7 or above hovers around 15. Some years bring far fewer. Some years, like 2021, brought as many as 16 alongside 3 separate quakes above magnitude 8. It is a chaotic system, not a predictable one, and that chaos is precisely why any attempt to declare a single year unusual has to be handled with care. But care does not mean ignoring what the numbers are actually showing. By the middle of August 2026, 10 earthquakes at or above magnitude 7 had already been recorded worldwide. That number alone, reached with roughly 2/3 of the year still remaining, sits close enough to the historical annual average that it deserves attention rather than dismissal. And when you widen the lens to include the smaller but still devastating quakes, the ones in the 5 and 6 magnitude range that have killed dozens in countries where construction cannot withstand strong shaking, the picture becomes even more striking. This is a year that opened quietly, gathered momentum through the spring, and then, in the span of about 10 weeks between June and August, delivered one catastrophic rupture after another with almost no time to recover between them. The first major tremor of significance struck far from any headline. On March 24th, the ocean floor near the Vava'u Island group in the Kingdom of Tonga shuddered with a magnitude of 7. 5, one of the strongest earthquakes recorded anywhere on the planet this year. Under almost any other circumstances, a quake of that size would dominate international news for days. This one barely registered. The rupture occurred at a depth of roughly 230 kilometers, deep enough that by the time the seismic energy reached the surface, it had been absorbed and scattered by hundreds of kilometers of solid rock. No deaths, no structural collapse, no tsunami. Just a powerful reminder, recorded by seismographs around the world, that immense energy had been released and dissipated with almost no human cost. It was the first sign of a pattern that would repeat throughout the year. Magnitude alone tells you almost nothing about what a quake will actually do to the people living above it. 9 days later, that lesson arrived in brutal, inverted form. On April 3rd, in the mountainous Afghan province of Badakhshan, the ground shook with a magnitude of only 5. 8, a fraction of the energy released in Tonga. And yet, at least 12 people died. In a region where homes are built from mud brick and stacked stone, where reinforcement steel is a luxury few can afford, where roads wash out every spring and rescue teams sometimes take days to reach a stricken village, even a moderate earthquake becomes an act of catastrophic violence. There was no tsunami warning to issue, no coastal evacuation to manage. There was simply the sound of walls coming down on people who had no time to run. In villages so remote that international aid agencies struggled even to confirm the full scope of what had happened. Badakhshan's earthquake would end up ranking near the very bottom of this year's list by magnitude and near the top by human tragedy, a distinction that would define the entire year to come. 2 weeks after that, on April 20th, the seafloor off Japan's Sanriku coast in Iwate Prefecture ruptured at magnitude 7. 4. For anyone with even a passing familiarity with Japanese seismic history, that name alone was enough to trigger a wave of dread. Sanriku is the same stretch of coastline that, 15 years earlier, produced the magnitude 9 catastrophe that killed nearly 20,000 people and triggered the Fukushima nuclear disaster, one of the defining tragedies of the 21st century. When this year's tremor struck, Japan's meteorological agency immediately issued a tsunami warning, and for a tense stretch of hours, coastal residents evacuated to higher ground while the entire country held its breath, remembering. This time, the ocean did not rise the way it had in 2011. No major tsunami materialized. The infrastructure Japan had spent a decade and a half reinforcing, the seawalls, the early warning networks, the evacuation drills repeated in schools every single year, appeared to have done exactly what they were designed to do. It was, in its own quiet way, one of the year's few genuinely reassuring moments, proof that preparation can blunt even a powerful blow from one of the most dangerous coastlines on Earth. But it was also a warning shot. The fault system beneath Sanriku had moved again, and nobody could say with certainty what that meant for the years ahead. 2 days after the Japan quake on April 2nd, an earthquake had already struck the Molucca Sea between North Sulawesi and North Maluku provinces in Indonesia, registering at a magnitude between 7, 3, and 7. 4, depending on which agency's instruments you trust. This one triggered a modest tsunami, waves reaching roughly 75 centimeters, enough to flood low-lying areas near the epicenter without producing the kind of devastation seen in larger tsunami events. More than 450 structures were damaged or destroyed, most of them in the small, remote Batang Dua Islands, where a single fatality and 4 injuries were reported. It barely made international news, but it added another entry to a growing tally. Another fault system releasing energy it had been storing for years. Another community left picking through the wreckage of homes that had stood for generations. Then came June, and with it, the moment the year's earthquake story stopped being a series of scattered incidents and became something the entire world was suddenly forced to pay attention to. On June 8th, off the southern coast of the Philippine island of Mindanao, the Earth ruptured at magnitude 7.8 at a depth of 57 kilometers. It was, and remains, the single strongest earthquake recorded anywhere on the planet in 2026. The shaking was felt across enormous stretches of the island. In General Santos City, a university building collapsed, its floors pancaking down in the kind of image that circulates instantly across social media and news broadcasts worldwide. At least 107 people were killed. Tens of thousands were displaced from homes that either collapsed outright or were rendered structurally unsafe overnight. And yet, in the grim mathematics of seismic disaster, the Philippines' quake, despite being the year's most powerful, would not be the year's deadliest. Not even close. Because 16 days later, an ocean and a continent away, something far worse was about to happen. On June 24th, the ground beneath northern Venezuela ruptured twice within 39 seconds of each other. First, a magnitude 7. 2 tremor, and then, before the first shockwave had even finished traveling through the crust, a second and even more powerful rupture at magnitude 7. 5. 2 catastrophic earthquakes stacked on top of each other in less time than it takes to read the sentence aloud, striking a country whose infrastructure had already been strained for years by economic crisis, whose building codes in many neighborhoods existed more on paper than in practice, and whose emergency response systems were operating with a fraction of the resources a disaster of this scale demanded. The north of the country and the capital, Caracas, absorbed the worst of it. Buildings that had stood through decades of Venezuela's turbulent history came down in seconds. Satellite-based damage assessments conducted afterward by researchers at Oregon State University estimated that more than 58,000 structures may have been damaged or destroyed across the affected region. A number so large, it is difficult to visualize as anything other than an abstraction, until you remember that every single one of those buildings was somebody's home, somebody's school, somebody's place of work. Official figures place the death toll above 6,300 people, by far the deadliest earthquake anywhere on Earth in 2026, and one of the deadliest anywhere in the world in the past several years. It happened in less than a minute, and its consequences will be measured in years of rebuilding, if the rebuilding ever fully happens at all. Barely 6 weeks later, the Earth struck again, this time in South America's northwest. On August 10th, a magnitude 7. 4 earthquake tore through western Colombia, its epicenter near San Jose del Palmar in the Chaco region. The rupture occurred at a depth of 100 kilometers. Deep enough that, under normal circumstances, the shaking at the surface should have been significantly dampened. It was not dampened enough. In the Andean foothill city of Pereira and across the wider region, buildings collapsed, roads buckled, and landslides tore down mountainsides already saturated from seasonal rain, burying stretches of highway and cutting off entire communities from rescue teams. More than 250 people are currently estimated to have died, with search operations continuing for days afterward as crews fought through blocked roads and unstable terrain just to reach the people still missing beneath the debris. After Venezuela, this was the most consequential earthquake of the year for all of Latin America, a second devastating blow to a region that had barely begun to process the first. And then, just 5 days after Colombia, on August 15th, the Earth delivered its most recent gut punch, the Flores Island rupture described at the very beginning of this account. A magnitude 7 earthquake struck at a depth of only 10 kilometers, shallow enough to transmit almost its full force directly to the surface. The epicenter sat roughly 68 kilometers north-northwest of the city of Ende, in East Nusa Tenggara province, a stretch of coastline that carries its own grim history. In December of 1992, the same general area was struck by a magnitude 7, 5 earthquake that triggered a tsunami killing more than 2,500 people, one of the deadliest disasters in Indonesia's modern history. This time, tsunami waves reached the coast at under a meter, far smaller than the 1992 catastrophe, but the shaking itself proved devastating enough on its own. More than 300 houses were destroyed or damaged. The death toll climbed steadily over the following days as rescue teams reached increasingly remote areas, rising past 20, then 38, then approaching 50 and beyond, a grim, incremental count that is tragically familiar to anyone who has followed disaster reporting from this part of the world. Villages near the epicenter remained largely cut off, their roads buried under landslides, their communication lines down, their true scope of damage still emerging days later. More than 500,000 people on Flores Island alone are estimated to have experienced very strong shaking, with millions more across the wider region feeling the tremor to varying degrees. Astonishingly, on that very same day, thousands of kilometers away on the island of Sumatra, the Earth moved again. A magnitude 6. 9 earthquakes struck northern Sumatra at a depth of over 170 kilometers. Its tremors felt as far away as Malaysia's Penang and Perak states across the Strait of Malacca. Because of its extreme depth, this quake caused no reported casualties or damage, but its timing, striking on the exact same day as the deadly Flores rupture more than 1,500 kilometers to the east, meant that for a few hours on August 15th, Indonesia had 2 major earthquakes, shaking 2 entirely different regions of its vast archipelago simultaneously. Within days, the same corner of Sumatra would register yet another quake, a magnitude 6. 4 event on the 16th, followed by continued aftershock activity through the following week. For the people living along this stretch of the Ring of Fire, the ground has felt less like solid earth and more like something perpetually unsettled, something that has not finished moving. It helps, too, to place 2026 against the backdrop of the year that came directly before it. In 2025, the single strongest earthquake anywhere on the planet reached a staggering magnitude, 8. 8 off the coast of Russia, an event roughly 20 times more powerful than any single rupture recorded so far in 2026, and one that still ranks among the largest earthquakes ever instrumentally recorded anywhere on Earth. That same year, a magnitude 7. 7 earthquake in Myanmar killed more than 5,000 people, and the global death toll from earthquakes across all of 2025 climbed past 8,000. Compared against that backdrop, 2026 has not yet produced a single event as powerful as Russia's 8. 8, and its overall earthquake count sits noticeably lower than 2025's tally by the same point in the calendar. But the death toll tells a different story. Venezuela's June disaster alone has already pushed this year's cumulative fatalities past 6,000, closing in on totals that took a full 12 months to accumulate the year before. Fewer earthquakes, in other words, but a death toll climbing at a pace uncomfortably close to one of the deadliest years in recent memory, a reminder that raw earthquake counts and human cost do not always move in the same direction. Lay all of these events side by side and a difficult truth emerges, one that every seismologist will tell you if you ask them directly, and one that this year has illustrated with almost cruel precision. Magnitude is not destiny. It is only one variable in an equation that also includes depth, distance from population centers, soil composition, and, most brutally of all, the quality of the buildings that happen to be standing above the rupture. Tonga's magnitude, 7. 5 quake, deep beneath the Pacific, killed nobody. Afghanistan's magnitude, 5. 8 quake, a fraction of that energy, killed 12 people trapped inside structures never designed to withstand shaking of any kind. The Philippines absorbed the year's single strongest rupture and lost just over 100 lives, a devastating toll by any measure, but a fraction of what followed 16 days later in Venezuela, where a marginally weaker double earthquake killed more than 6,000 people because it struck a country whose infrastructure had already been hollowed out by years of crisis before the ground ever started shaking. This is the uncomfortable core of earthquake science. The disaster is never really about the earthquake alone. It is about what human beings had already built, or failed to build, in the years before the ground decided to move. This is also where the story shifts, because up to this point, the narrative has been about counting. Counting quakes, counting deaths, counting collapsed buildings. But underneath the counting lies a harder question, one that seismologists have been forced to confront publicly as 2026 has unfolded. Is this year actually unusual, or does it simply feel unusual because of how the disasters have clustered? The scientific answer is uncomfortable in its honesty. Experts who study long-term earthquake frequency point out that 10 to 11 earthquakes above magnitude 7, reached partway through the year, is not statistically extraordinary when measured against decades of historical data. Some years have produced 16 or more. The planet has, within the past decade alone, produced years with 3 separate magnitude 8+ events, dwarfing anything 2026 has generated so far. By the raw numbers, this year sits within the normal range of seismic variability, not outside it. And yet that same statistical normalcy is precisely what should unsettle you, because it means the platform is not slowing down. If 10 major earthquakes have already struck by the middle of August, and the historical average for an entire year sits at around 15, then simple arithmetic suggests the planet is on pace to meet or exceed that average before December arrives, with 4.5 months of seismic activity still to come. Some of those years that produced the biggest totals did not spread their earthquakes evenly across 12 months. They clustered the way 2026 is clustered, with long quiet stretches punctuated by violent bursts of activity in specific regions, as stress transferred from one fault segment to another. Seismologists are careful, appropriately careful, never to claim they can predict exactly when or where the next major rupture will strike. Earthquake prediction, in the precise sense of forecasting a specific quake days or weeks in advance, remains scientifically impossible with current technology, and any voice claiming otherwise should be treated with immediate suspicion. But statistical forecasting is a different discipline entirely, and by that measure, the expectation is sobering rather than reassuring. Based purely on this year's pace and the planet's long-term historical average, geophysicists estimate that somewhere between 4 and 6 more earthquakes of magnitude, 7 or greater, are statistically likely to strike before 2026 comes to a close. Nobody can tell you which fault line. Nobody can tell you which country will wake up to collapsed buildings next. But the math itself, cold and indifferent to human suffering, suggests the year is not finished delivering catastrophe. What makes this particularly urgent is where the remaining risk is concentrated. The regions already struck this year have not necessarily released all of their stored stress. Flores Island's fault system, the same one responsible for the devastating 1992 tsunami, continued producing aftershocks for days after the August 15th rupture, some strong enough to be significant earthquakes on their own. Aftershock sequences of this magnitude can persist for weeks or even months, and history has shown that major aftershocks occasionally rival or approach the strength of the original rupture. Northern Sumatra, struck twice within days in mid-August, sits along one of the most seismically loaded subduction zones on the planet, the same general fault system responsible for the catastrophic 2004 Indian Ocean tsunami that killed more than 200,000 people across a dozen countries. Colombia's Chaco region, still digging out from the August 10th disaster, sits at the collision point of the Nazca and South American plates, a boundary capable of producing quakes far larger than the one it just delivered. And Venezuela, already reeling from the deadliest earthquake anywhere on the planet this year, remains a country whose reconstruction capacity was limited even before 58,000 buildings were damaged or destroyed, meaning any additional seismic activity in the region would strike a population with almost no remaining margin for absorbing further shock. The human cost of a year like this extends far beyond the immediate death tolls, staggering as those numbers already are. In Venezuela, tens of thousands of families now face the prospect of rebuilding homes in a country whose economy was already in crisis before June 24th, a task that could take not years, but decades, given the scale of destruction. In Colombia, landslide-blocked roads continue to isolate communities in the Chaco region, complicating not just search and rescue, but the basic delivery of food, water, and medical supplies to people who had almost nothing before the earthquake and now have even less. In Indonesia, the pattern of major earthquakes striking one region after another, Maluku Sea in April, Flores in August, Sumatra also in August, has stretched the country's disaster response agencies across multiple simultaneous crises, testing a national emergency system that, however well organized, has finite resources and personnel. And in Afghanistan, where the year's weakest major quake produced one of its most human tragedies, the underlying problem was never really about seismology at all. It was about poverty, about construction standards, about the absence of the infrastructure that turns a survivable tremor into a mass casualty event. Every one of these disasters carries its own distinct set of causes and consequences, but together they form a portrait of a year in which the Earth has repeatedly tested the gap between human preparation and geological reality, and in far too many cases, that gap has proven fatal. There's also the matter of what happens next inside the disaster zones themselves, long after the news cameras move on to the next tremor somewhere else on the planet. Earthquake recovery does not end when the shaking stops or when the death toll is finalized. It stretches on for years in the form of displaced families living in temporary shelters, of children attending school in tents because their classrooms are structurally condemned, of local economies that depended on now destroyed infrastructure struggling to function at all. In Flores, the true scale of damage was still emerging days after the August 15th quake, with entire villages near the epicenter cut off by landslides, their populations effectively invisible to relief agencies until roads could be cleared. In Colombia, aid workers described a race against time, not just to find survivors, but to reach communities before the rainy season worsened the landslide risk further, turning a geological disaster into a secondary humanitarian crisis driven by weather. These are the parts of the story that rarely make it into a single dramatic headline, the slow, grinding aftermath that continues long after the world has stopped watching, and it is happening simultaneously right now across at least 4 different countries on 3 different continents, all because the Earth chose this particular year to release so much of its stored energy in such a short, brutal span of time. There's a particular kind of dread that settles over seismologists during years like this one, a dread that has nothing to do with superstition and everything to do with statistics that refuse to offer comfort. They know, with total scientific confidence, that the Earth's crust does not care about calendars, does not pause for news cycles, does not wait politely for the world to finish processing one disaster before delivering the next. They know that somewhere on this planet, right now, stress is accumulating along fault lines that have not moved in decades, in some cases in centuries, and that the release of that stress is not a question of if, but purely a question of when. What they cannot tell you, what no scientist alive can currently tell you with any precision, is which of those fault lines will be next, or how many more will fail before this year finally ends. The Ring of Fire alone hosts dozens of subduction zones capable of producing magnitude 7 or larger ruptures, any one of which could be next. Beyond the Ring of Fire, the collision zone, stretching from the Himalayas through Iran and into the Mediterranean, carries its own immense stored energy, a region responsible for some of history's deadliest earthquakes, and one that has, so far in 2026, remained relatively quiet, a silence that offers no reassurance to anyone who understands how these systems actually work. So, where does that leave the rest of this year? 10 to 11 major earthquakes recorded so far, a global death toll already climbing well past 6,000, a series of disasters spanning the Pacific, South America, Central Asia, and Southeast Asia, and a statistical expectation, grounded not in speculation, but in decades of recorded seismic history, that several more catastrophic ruptures remain likely before December 31st arrives. The regions most exposed, Indonesia's overlapping fault systems, Colombia and Venezuela's shared tectonic boundary, the volcanic arcs stretching from Japan through the Philippines, carry populations numbering in the hundreds of millions, many of them living in structures that were never designed to survive what geological history says is coming eventually to every seismically active region on Earth. Nobody watching this unfold can tell you the date. Nobody can tell you the place. What the numbers make clear is only this. The year is not over, the Earth has not finished moving, and somewhere beneath a city or a village that has no idea what is coming, the pressure is still building.